Okay, so this is chapter 6, which is a chapter about trigonometry. In particular, it's about what are called reciprocal trig functions. So the chapter looks like this. First of all, we're going to see what these reciprocal trig functions are. They're called sec, which is short for secant, but we're just going to say sec, cosecant, or we're just going to say cosec, and, well, tan we know already. We're actually going to talk about cotangent or cot. So sec, cosec, and cot. And we're going to look at their graphs to see what they look like. We're going to then use these to solve trig equations. So this is going to link very heavily with the previous chapter of radians and year 12 trig. We're going to try proving questions. So again, quite similar to year 12. And then we're going to talk a little bit about inverse trig functions. So this is really quite confusing, this part, because the vast majority of this chapter is about reciprocal trig functions. Okay, an inverse trig function, which we'll see at the end, is actually something different. Okay, right. So to start with, what are these functions? So you can see here I've put the third letter in red because it's going to give you a big clue each time. So sec, the third letter is C. So sec is 1 over cos. Okay. Cosec, the third letter is an S. So that means you've got an S in the denominator. You've got 1 over sine. And cot, yes, it is 1 over tan. However, it's normally more useful to use this version here, cos over sine. Remember, tan is sine over cos. So the reciprocal, what we've done is we've changed them, so it's cos over sine. Okay. So first of all, let's just practice some basics. And I'm just going to talk through some results here. So these are all in radians. Okay, so pi over 4, just a little reminder for you that pi radians is equivalent to 180 degrees. Okay, so if we say pi over 4, we are talking about 45 degrees. So if somebody asks you to find cot of pi over 4, the idea is that first you're going to convert it to, to express it in terms of the trig functions we're more familiar with. So cot, remember, is 1 over tan. So I'm going to work out tan of 45 degrees, tan of pi over 45, which is 1. And then I just do 1 over that, and I get my final answer of 1. Okay, so this is the general way we're going to do these. Sec, so sec, the third letter is C. So when we say sec of pi over 4, what we're going to do is we're going to work it out by doing cos of pi over 4, and then we'll do 1 over. So you get 1 over root 2. I would actually do this a little bit differently. I would just think about if you do cos 45 or cos of pi over 4, you get this. So the reciprocal is when we change those around, okay? So you just get root 2. So I wouldn't do this this way, in fact. Cosec, so cosec, it's an S. So we think about sine of, this is 180 over 3, so this is 60. So you would normally get root 3 over 2. So then we do the reciprocal of that, 2 over root 3, as written there. Okay, and you get the hang of this. So of course it's much quicker if you know your exact values, like we've got up here. All the rules and symmetries and reference to the unit circle, this stuff is all useful again, okay? Because what we're doing here is really our year 12 trig, and then we're just finding the reciprocal. We're just turning them upside down. Okay, so let's just do one more very quick example. So we could do this the other way around, for example. So cos of 60 degrees. Well, cos of 60, you may remember that that one is actually a half. So if you know cos of 60, cos, the third letter would be sec. Well, that would tell you then that sec 60 is 2. Okay, so all the stuff that we've done before is useful, and you're going to see that in the chapter. It's reflected in the chapter. A bunch more questions here for you to practice, and you would do sine of 30, turn it upside down, do the reciprocal. Tan of 45, do the reciprocal. Sec, do cos of 150, do the reciprocal. okay, and so on and so on and so on. Some of these results are quite interesting. So you might remember that tan of 90 is undefined, but cot of 90, well, this one we can actually work out. This one is going to be 0. Okay, because instead of sine over cos, instead of sine of 90 over cos of 90, where this caused the problem before, you're going to have cos of 90 over sine of 90. Yeah, and the cos of 90, 0 over 1, so it's actually just going to be 0. Okay, also that's a good example of how you might want to use cos and sine instead of tan, because if you use tan, that might give you the impression that that's not answerable, when in fact it is. What do these graphs look like? Well, in front of you here, I've got in red here, this is a sine graph. It starts at 0, it rises, and every 90 degrees something interesting happens, is the way I like to think of that. So you can piece together well, if this is a sine graph, what's the third letter? It's going to be cosec. So this must be a cosec graph. I've taken some easy points, like the point 1. Well, what's the reciprocal of 1? It's 1. So that point is not going to move. If I took a point of a half, which is here somewhere, the reciprocal would be 2. A half would be 2 again. If you try picking a point of 0, you're going to have a problem there. And that's going to be undefined. So that's why it sort of goes up here on the sides. Sine has symmetry, so cosec has symmetry. If we try negative numbers, like down here, -1, the reciprocal of -1 is still -1. Minus a half is -2, and so on. So you get this shape as well. And you have these asymptotes that are drawn in these vertical lines. So this is how you could remember what the cosec graph looks like. So I don't remember this off by heart. I just think of a sine graph and do what I've done here on the board. Have a think about a cos graph then. So a cos graph sort of looks something a bit like that. So what's a sec graph going to look like? Well, some of the points are going to be shared, and then you're going to have this divergence again. Okay, so if I show you the result, this is a cos graph here, and then again we've done this part here to help us sort of think about what a sec of x graph would look like. Now, tan's a fair bit more challenging, so I've done tan as well here below. So in black is a tan graph, and we can still do this piecemeal strategy of thinking about nice coordinates to piece it together. So on a tan graph, there are some 1s, so reciprocal of 1 is 1. You could pick some values here, so if you imagine a half is there, for example, then yes, 2 is up here still. 0, when you do the reciprocal, that's going to give you an asymptote. So everywhere you have 0 on the original tan graph is where you're going to have an asymptote on here. And it applies the other way around. If you think about a value here getting infinitely large, 1 over an infinitely large value means you're going to be dividing by a lot. So a million turns to a millionth. So a very big positive number becomes a very small positive number. And so it is for sort of negatives as well. Like a very negative number becomes a number that's only just below 0. A number that's a very small negative number becomes a very, very negative number, like that. So you end up with sort of something that looks a bit like it's reflected in some parts, but it's also shifted as well. So the asymptotes move. So unfortunately, cot's not as nice, I would say, but you can still derive it sort of as we've seen there in the questions. Okay, so that brings us towards the end of the very, very first section then. So what are the reciprocal trig functions? They are sec, cosec, and cot. cot mostly used as cos over sine in the rest of these videos you're going to see. And of course we could use our calculators to piece them together if we needed to, but I find a nice sketch and doing the reciprocal of the values in here tends to be quite a nice way to derive those graphs.